Hello, I'm Jessica Begonia, Director of Marketing for EnviroGo, a division of Alloway.
And I'm John Hoffman, owner of Alloway and Chief Executive Officer. Last year, Alloway had the privilege of partnering with several organizations on an opportunity to research the effectiveness of cascading grassed waterways in mitigating pollution to receiving waters from solids and nutrients associated with agricultural fertilizer. Due to the unique sampling challenges associated with this project, innovative sampling techniques were necessary. The limited term of sampling for the project and the desire of stakeholders to share data online as the project evolved, along with strict regulatory requirements met to keep composite samples cold, required an innovative approach. This presentation will explore innovative ways to collect grab and composite samples, along with monitoring and recording weather using a mobile sampling platform with net zero energy usage. Why was an innovative approach needed for this project? Well, more traditional methods do not always work. We are often asked to provide proposals and solutions for projects where permanent or semi-permanent installations are too costly. They cannot readily mobilize and shift position easily as the project unfolds. They may take up too much room. A different approach was needed to meet the request for proposal. This photo is a great example of a more traditional approach to agricultural stormwater sampling. These setups usually feature a permanent or semi-permanent installation. They take up a lot of space. The equipment is not easily moved, and there are limited options for rental or leasing of equipment in a turnkey solution, especially for short-term projects. This works well for long-term multi-year projects. The systems are robust and they have some advantages. These traditional installations are powered through an external battery or the batteries in the composite samplers and flow meters. Some have solar panels that are mounted and immobile, taking up more valuable land from the farm operation. The solar panels recharge the batteries and primary measuring devices. Again, these devices that provide the means to measure can be used with a more innovative approach. The containers that hold the sampling equipment are not easily moved, and space is very limited for sampling and flow monitoring equipment. Traditionally, samples are collected in the body of the composite sampler. This does not allow for thermal preservation as required by 40 CFR Part 136 of the Federal Register for environmental testing requirements. Space is often limited for inclusion of a refrigerator, and there are limited power sources to accommodate refrigeration. In addition, traditional setups don't have space for on-site testing like ORP, pH, conductivity, etc. With no on-site bench space, field technicians are forced to work with whatever space is available, maybe the bed of a truck, back of a van, etc. Traditional methods don't always work. They are fixed structure, not mobile, large footprint, they take up space, requires separate external solar panels. There's often no thermal preservation of samples, often insufficient power for things like sample refrigeration, and very costly. So, why the need for innovation? Well, a smaller footprint with more capacity is often needed. The farmer may not want a permanent installation in the field. Mobility and flexibility of changing sampling points. Some projects are short-term and don't warrant a large sunk investment. The return on investment is too low on a permanently installed system. Customers are looking for greater efficiency and lower price. Telemetry can be incorporated, providing security and access to real-time data online, and power options can provide refrigeration of samples as they are collected. So we know that traditional platforms don't always work, and there is a need for innovation. We started making a list of critical success factors that would meet the needs of a diverse range of projects. A top tier priority was mobility, being able to perform environmental sampling and analysis on the go, to be able to deploy the sampling units in remote locations and easily maneuver the equipment into position. Our clients also wanted the unit to be insulated so that it could be heated and protect against the weather to prevent samples from freezing. Our employees identified easy cleanup as a key critical success factor. So having a unit with running water for hand washing or rinsing a pH probe or a shovel was a must. Other critical success factors: the capacity for composite and flow proportion sampling. The sampler with a capacity to interface with a flow meter and a primary measuring device. Refrigerate the samples being collected in accordance with 40 CFR Part 136, and devices controlled through telemetry. To meet the needs of our clients involved with stormwater sampling events, we wanted to ensure that these innovative units included onboard weather stations so weather data could be recorded from the actual site at being sampled. With all of this sampling equipment and measuring devices, we knew that flexible and high-capacity electrical systems were needed. And since many sampling events occur over a period of weeks or months, onboard solar panels to feed the batteries with renewable energy were very important. With many of our customers needing on-site measurements like pH, DO, conductivity, we knew that on-site bench space was a critical success factor. In addition, interior and exterior lighting would be a plus to allow technicians to safely work in a variety of conditions. And onboard security would help ensure all of the equipment and gear is safe while also maintaining sample integrity. Knowing the critical success factors, we set out to create an innovative solution through EnviroGo trailers. These customized sampling and monitoring packages are designed to provide everything needed in a convenient mobile unit. With these trailers, field technicians can quickly mobilize in order to collect stormwater samples and conduct monitoring and sampling over extended periods of time in remote locations, even those that lack traditional power sources. The onboard Yeti Gold Zero batteries plus the high-capacity Merlin solar panels provide a reliable power source that is environmentally friendly. In addition, the trailers are equipped with weather monitoring stations that record rainfall and weather patterns at the actual sampling site.
So using the EnviroGo trailers, Alloway partnered with the Ohio Department of Natural Resources, Defiance County Soil and Water Conservation District, the City of Defiance, and The Ohio State University in the spring of 2021 to evaluate the effectiveness of cascading grass waterways in containing solids and nutrients associated with agricultural runoff. So just a quick explanation about cascading grass waterways. Cascading grass waterways are a series of shallow basins located in a grass waterway. These cascades are a prescribed best management practice designed to help farmers more effectively manage water on their land and provide erosion control. It's believed that these systems help slow down water, settle out the sediment, and filter nutrients in the water by allowing it to seep through the soil profile. However, there is limited scientific research investigating the effectiveness of these systems. So to assess the effectiveness of these cascading waterways, Alloway deployed 2 EnviroGo trailers from mid-March to early June in a farm field located in Defiance, Ohio. One trailer was positioned at the start of the cascading waterway and one at the end, as shown by the aerial photo in the presentation. EnviroGo's automated sampling platforms and weather monitoring stations enabled Alloway to perform sampling and monitoring over a period of 3 months in this remote location. During the deployment, we were able to collect 5 rainfall events and 1 snowmelt. We were able to use our March 19th event as our baseline before fertilizer was applied. And then the preceding events were all post-fertilizer application. During that 3-month deployment, the solar panels were able to keep the batteries fully charged, so we never had to remove the batteries and take them back to the shop. Grab samples were collected using the Nalgene Stormwater mounting kit, deployed in a ditch mount formation by digging holes 12 inches deep by 5 inches wide in the grassways before and after each Cascade pool, as shown on the map. So grab samples as you move through the treatment system would count down from 4, 3, 2, and finally 1 at the end of the treatment. Grab samples were collected immediately after the water started to flow over the device. The stormwater sampler was capable of collecting 1 liter of sample, and this represented the first flush of stormwater runoff through the grassway. The Nalgene stormwater sampler collection funnel was equipped with a floating ball valve that seals off the sample chamber after the bottle is full, preventing commingling and dilution by later runoff. The mounting tube is designed to shed falling rain and collect only runoff when positioned in a ditch mount. The Yolink moisture detection devices were positioned inside the Nalgene sampler mounts on top of the bottles, with the moisture sensors positioned at the intake level. The moisture detector used the hotspot to signal if a sample was detected, and then the Yolink devices recorded the dates and times of detections to the cloud, and that information was used to document the sample times on the chain of custody forms and analytical reports. When moisture was detected at the grab sample 4 location, which is the initial entry to the east waterway, the Dinko peristolic pumps were programmed to start collecting a composite sample at east cell number 3 after about a 30-minute delay. And we also had a second composite sampler set to collect when moisture is detected at grab 1, which is the final discharge in the east waterway. The composite sampler locations were shown here on the map, and the composite samplers collected 250 milliliters every 10 minutes for a total of 1 liter, with a total collection time of half an hour. The refrigerator inside of the EnviroGo trailer allowed us to maintain thermal preservation as required by the testing methods according to 40 CFR Part 136. The samples were kept cold until our field technicians could come on site to collect the samples. The refrigerator was turned on using telemetry enabled through the on-site hotspot when samples were detected at grab 4. So this helped us to limit the power draw on the battery, so the refrigerator was only in use when we needed to keep the samples cold. Weather data was also recorded from the actual sampling location, and that data was stored in the cloud so the analytical results could be evaluated in connection with weather patterns. From this, we found that we typically needed over half an inch of rain to generate grab samples in the grassway, but there was an exception on April 21st when we were able to collect with only about 1/5 of an inch of rain, but that was the exception rather than the norm for the sampling events we saw for the 3 months the trailers were deployed. So using the moisture detectors to determine when grab samples were collected, we were able to infer that untreated stormwater runoff was entering the end of the treatment train directly from the surrounding field rather than through the treatment process, thus affecting the evaluation of the results. When you compare the sampling dates and times with the locations of the samples as shown on the map, samples 1 and 2 at the end of the treatment process were often being detected before samples 3 and 4 at the beginning of the treatment process. So as you can see here, by the order of the event of sample collection on March 25th, samples were detected at the end of the treatment system before samples were detected at the beginning of the treatment system. So first sample collected was sample 1, and then 2, and then jumped to 4 and 3. So again, this suggested that there was quite a bit of untreated stormwater runoff entering the grassway at the end of the cascading waterway. In addition, visual observation of the topography of the land supported that hypothesis. And just kind of walking through here, you can see the same thing occurring again on April 21st event with samples 1 and 2 being detected here before samples 3 and 4. This plays an important role in our data evaluation. These grab samples represent the first flush of runoff entering the treatment system. So if the majority of the stormwater is not entering at the beginning of the treatment train, that affects the results and the evaluation of the effectiveness of the system. Evaluating the solids content of the samples also showed us an interesting picture. The solids content was highest in grab sample locations 1 and 2, which again, that's located at the end of the treatment system. So this supports the idea that untreated runoff was quickly entering those locations rather than going through the full treatment system. However, it's worth noting that we also saw a pronounced difference in the solids content when comparing the grab samples and the composite samples, suggesting that the Cascade pools were helping to settle out the solids before the stormwater entered the local watershed. So you can see that through the yellow arrows there on the graph. Those point to the composite samples at the east cell number 3 and east cell number 1. If you take the grab samples out of the evaluation and only look at the composite samples taken from the pool cells, then we're able to more easily see some of the effects of the treatment through the Cascades. The most pronounced effect is the reduction of nitrates through the cells, especially in the rain events closely following the fertilizer application that occurred a week before the rain event on March 26th. The nitrates in the pool at the start of the treatment system were 13 milligrams per liter, compared to the nitrates in the pool at the end of the treatment system, which were less than 1 milligrams per liter for the rain event on March 26th. We also saw a reduction in the nitrates during the rain event on April 21st. The nitrates went from 1.84 milligrams per liter to less than 0.05 milligrams per liter. Overall, more research is needed to understand the effectiveness of these stormwater treatment systems. Bruce Clevenger with The Ohio State University said it best when he stated, "As the on-site farm manager and field crops research designer at the Defiance County Agricultural Cascades monitoring project, I recognize the value of using automated sampling platforms to evaluate the effectiveness of cascading waterways to reduce pollutants in stormwater runoff. I'm encouraged by the preliminary results of the Defiance County Agricultural Cascades monitoring project, and the agricultural community will benefit from funding to continue similar studies as we evaluate various treatment methods for agricultural runoff." We are excited to partner with more organizations to continue to research the effectiveness of various treatment technologies in mitigating pollution from agricultural runoff. Senator Sherrod Brown has set aside FY22 appropriations for the continued research of agricultural runoff treatment. So we'll be searching for partners in this ongoing project, along with other sites where the monitoring platforms can be deployed in the spring of 2023. So if you know of any farm fields that have implemented the use of cascading waterways, drainage ditch modifications, or nutrient removal structures such as steel slag or other industrial byproducts, please let us know. And with that, we're going to conclude our presentation. We greatly appreciate your time and attention today.